Demands in the construction industry are continuing to increase rapidly. Engineers are in search more efficient processes that utilizes materials at its maximum potential. This greatly reduces the construction cost of a project. Manual labor, which is heavily relied upon since ancient times, is becoming more a thing of the past, especially in developed countries. Focus shifted to automation and mechanization. This new concept is called Industrialized Construction, and one of its applications is the use of concrete 3D printer. The first 3D printer was invented in 1984, and it is a process of making the three-dimensional solid objects from a digital file. Our research entitled A Qualitative Report of the Benefits of Concrete 3D Printing as a Form of Industrialized Construction will give you more knowledge about this.
Research design. This study is a qualitative research. Qualitative research is a systematic, subjective approach used to describe experiences and give them meaning. This study aims to answer if 3D printing is ready for industrialization. The researchers use the grounded theory method. The grounded theory method is used to discover what problems exist in a social scene and how a person handles them. It involves formulation, testing, and redevelopment of propositions until a theory is developed. Data gathering instruments. The researchers will conduct a detailed gathering of information about concrete 3D printing. The grounded theory method is applied in this study in order to develop a theory which will deepen the understanding of concrete 3D printing.
For the findings, 3D printing is characterized by giving space for creativity in automated process. In the past, fine details had to be crafted completely by hand. But now, with 3D printing, a pattern can be repeated as many times as you want. 3D model can be created using CAD or 3D scanners. So far, we have three technologies that we can use in 3D printing. The first one is the robotic arm extruder. This is a robotic arm that extrudes concrete materials from the nozzle while building the house layer by layer. The second one is the metal printing, wherein industrial robot was allowed for 3D printing metal structures in 6 axes. The third one is sand 3D printing, wherein machine spread the sand powder and hardens it by a binder.
The modern construction industry is known for its ability to adapt rapidly that can advance the building sector. One of the innovations in this area is concrete 3D printing, in which automation, no required formwork, and nearly no materials wasted makes it more beneficial than traditional techniques. Low carbon dioxide concrete approach are now being explored by using supplementary cementitious materials to lessen the consumption of Portland cement. A new method of cost calculation separately analyzes the components printing, components assembly, and on-site concrete 3D printing. The cost calculation between the conventional construction and construction with the influence of concrete 3D printing showed that human labor cost, material cost, and machine cost was reduced in concrete 3D printing.
For construction stakeholders, finishing a project earlier means thousands and millions of profits. Fortunately, concrete 3D printing is an emerging technology nowadays. It can reduce construction duration and can be extremely beneficial during an emergency situation. This can be proved by the study of Ion et al. Entitled The Reduction of Construction Duration by Implementing Contour Crafting or 3D Printing. A structural analysis of a bungalow that was 200 square meter in area and 3 meters in height was conducted. The time it took for the 3D printer and conventional method to finish the building simulation was 29.5 hours and 90.5 hours respectively. 3D printing is faster since the concrete used cures at a much quicker rate and does not need to use the conventional formwork. Also, it can be further improved for quicker and better performance.
Concrete 3D printing can create optimal structural forms. Engineers at UK-based building design firm Arup have come up with a design method for 3D printing structural steel elements to be used in construction projects. It will specially enable complex designs to cost less. Another application is the bridge, which is constructed of 44 hollowed-out printed concrete units, while the handrails are divided into 68 units. The bridge components have been printed from composite materials containing polyethylene fiber concrete to match the structural performance of conventional materials.
An application of concrete 3D printing being capable of reducing labor cost is a 3D printed office designed for the United Arab Emirates National Committee headquarters for the Dubai Futures Foundation. It's named Office of the Future and is a fully functional building featuring electricity, water, telecommunications, and air conditioning systems. The project ultimately reduced 50 to 80% of labor cost and 30 to 60% of construction waste. Lastly, talking about concrete 3D printing's time-saving capability, a Russian company specializing in 3D printers, APScore, built an entire contour-crafted house in just less than 24 hours, from concrete walls to partitions and to building envelope.
Industrialized construction promotes the advancement of construction processes by mechanization and automation. And concrete 3D printing fulfills three of its goals. First is to improve quality by creating optimal structures through the integration of robotics, a visual modeling software, and physically manifesting it by just pouring concrete into molds. Second is to increase the productivity and reduce cost. It is done by targeting those repetitive patterns and using sustainable materials. And last but not the least is to fast-track the pace of construction. All the processes involved are fully programmed, which means human errors are eliminated, which are a common form of delay.
Considering the impact brought by the technology to our society, 3D printing, though relatively new, is one of the most promising aspects of it. When it comes to the benefits it can provide, given its wide range of applications, as well as its limitless potential for improvement. 3D printing, specifically intended for construction, has remarkable potential as a form of industrialization construction because it can create optimal structural forms, lower labor cost and construction cost, and has time-saving capabilities. As shown throughout the paper, concrete 3D printing improves the overall quality and the rate of construction by creating optimal structural forms. It also increases labor productivity, substitutes labor-intensive processes with machines, and reduces human labor, material, and machine costs, and as well as the entire time frame of a project.